Hello, everyone. Thank you for joining us today. My name is Yasmina Greco. I am with O'Reilly Media, and I will be your host for today's webcast. As we get today's event started, we'd like to say a big thank you to MemSQL for sponsoring our webcast and let you all know many businesses are discovering that legacy disk-based databases are unable to deliver the performance and scalability needed to keep up in today's fast-paced world of business, and are now exploring in-memory technology that enables them to make better data-driven decisions with real-time analytics, accelerate application performance, and discover competitive advantages. In today's webcast, Mark LaRosa, Director of Solutions Engineering for MemSQL, will look at the benefits of in-memory technology and the business value it brings. In his role at MemSQL, Mark ensures that MemSQL's partners are able to exceed their goals for real-time analytics and big data management projects. Mark was previously Principal Architect at Coraid, where he was responsible for technical design and implementation of Coraid's EtherDrive technology at the company's largest and most strategic customers worldwide. He also spent several years in user experience research and design at Google and was the founder of a successful IT integration company. Folks, I will turn the program over to Mark in just a moment, but first I'd like to go over a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Mark. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Mark, please preface them with a capital letter Q so we know that they're for him and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is StrataConf, all one word. If you should have any trouble with the event, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. If you have choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is to close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Mark for his presentation. Hello, Mark.
Good morning, and thanks so much for the introduction and to everybody on the line out there for attending this morning. Certainly appreciate everyone's time. Looking across some of the diverse attendees that we have today, we're coming across almost 58 countries, it looks like, so it's very much a privilege to be speaking to kind of such a broad spectrum of folks, and I think we can definitely gather some rich detail about what everyone's doing and how to best solve some of these issues by kind of hearing from you guys as well. So definitely, to the earlier point, please make use of the Q&A window. We'll definitely save some time at the end to go through that. So you've kind of heard a little bit about my background as well. I just want to kind of kick things off by talking a little bit about the current state of in-memory databases. So just to give you kind of a quick agenda and rundown, we're going to be addressing a couple of key points. The first thing is we want to cover real-time big data challenges and why legacy databases don't solve these things. There are some very specific reasons, and obviously you're probably familiar with many of them. What are some of the best use cases for in-memory databases that we see and also sort of that we've observed from other industry experts? How are customers using in-memory databases to solve their big data problems? So specifically, people that have the budgets that have actually invested in the technology, what are they actually doing? We'll also provide you with a live demonstration of MemSQL's in-memory database platform. So this isn't a video. We'll actually show you a live running system and give you an idea of what's possible towards the later part of the presentation. And then, of course, after you've seen all these things, how do you get started with it? We'll be covering ways to kick that off and get it done very, very quickly and easily. So the first thing we want to do is kind of kick off with a poll. As I mentioned, I'm pretty impressed with kind of some of the backgrounds of the folks on the phone here, and so I think it would be very valuable to gather, your sort of opinions on this. So the first thing I'm going to do is push a poll, and so you should be seeing right now an ability to actually answer this. And we just want to understand, in your organization or for your purposes, what are some of the biggest challenges that you're having in regards to big data? If you have a chance to kind of take a minute to answer that, it would really help us to sort of craft the presentation and shape it to the rest of the, and we'll also obviously share the results, of course. So if you could just take a minute to do that, I'll wait just a moment. Great. So as these things are coming back, you can see here that the kind of biggest, the biggest one we're seeing here is obviously setting up, maintaining, and integrating architecture and infrastructure. This is actually very much in line with what we were expecting. It's very, very difficult and complicated to deal with big data in today's world, especially when it comes to integrating multiple sources. So I think that the good news is the remainder of the presentation really covers specifically with regard to those results, and we'll definitely make sure to hit on those points exactly along with some of the others as well. So the next thing we want to really come on to is obviously those are what we've heard from the audience. Here's what Gartner thinks from a real-time big data challenge perspective. The really key points to take away here that people are struggling with: how do I gain value from big data? I have all this data. I know that it's potentially useful. What do I do in order to manipulate it and actually extract more value from that? When you do that, it does involve integrating multiple data sources like we just saw from the poll. We deal with sensor data, machine data, maybe it's a web application, event stream, those types of things. All of these things have to come together and somehow be mashed together and tangible in some way. So how do we get there? In order to do all these things, we have to maintain and manage infrastructure and architecture, also a big pain point as we just saw in the poll. And all of this, of course, yields application performance when things are done properly. So there are some specific issues with legacy databases that really prevent us from tackling these. And some of these are probably very familiar to many of you that are administrators of these technologies. The first and probably most important is the fact that slow disks and CPUs really bottleneck performance. Ultimately, that is the biggest pain point we see. You fundamentally have a very difficult time overcoming everything else if you're bottlenecked at these layers. Assuming you can solve performance, then you're dealing with the complexity. So you're dealing with managing, maintaining, and ingesting from multiple data stores. Assuming you tackle that, you have to be able to scale this. Overnight, you might notice that you have a 10x explosion in user growth. If your business is going well, or if there's an event that happens that's interesting, you need to be able to scale on a dime and be able to do that without having to buy proprietary vertically scaled hardware. And that, of course, is because legacy licensing costs are very substantial and generally very unpredictable. And that's something that, unfortunately, we're all too familiar with, myself as an operator background as well. So that's really what we're here to talk about today. What can in-memory databases do for us, and what are they best suited for? So the first thing is we need to be able to deal with fast data processing from multiple data sources. This is coming in from machine data, clickstream data from the website. It could be traditional standard relational data, things like that. We have very demanding time requirements. You need to be answering questions in real time every second, and you need to be running analytics reports as you're ingesting data. So that not only means answering questions in seconds, but it also means dealing with concurrency, dealing with ingestion as well as analytics at the same time. So we need to be able to accomplish both. Fast data access as well as ingestion. We've seen customers that are dealing with on the order of millions of transactions per second coming in from thousands of sources, and they simultaneously need to be able to capture as well as access that data. And then, of course, mixed OLTP and OLAP workloads. Kind of speaking exactly to the point we just made, you need lots of transactions, but you also need to do simultaneous analytics. That's really what in-memory technology is ultimately best suited for. So knowing the technical reasons for why in-memory works better, how do customers benefit and take advantage of in-memory technology? So the first and most obvious thing, dropping in an in-memory database will speed up your underperforming application. It's still SQL, so you don't need to make significant changes. That's probably one of the most common things we see is just accelerate existing SQL. But in addition to that, we want to enable real-time BI reporting. Most reports and analysts have agreed that, surprisingly, in the enterprise, from the time that a business unit wants to ask a new question until the time that it actually gets asked can be as long as 9 months. And that is pretty staggering when you think about it. We're really talking about answering specific questions in real time within seconds. That's really what you want to use in-memory for. Powering operational analytics. So again, operational analytics is something that you need to know about immediately. You need to respond to events as they happen and protect particular anomalies perhaps. Building applications with event stream data. Perhaps you're running an online game service or you have a website where customer interaction is valuable data and you need to respond to that, maybe to display ads or to change an interaction experience. All of that must happen in real time. Or perhaps you want to incorporate complex triggers and alerts. So, again, reacting and responding to situations where there's an enormous amount of data that needs to be captured and analyzed. These are all very, very good use cases for an in-memory technology. So for many of you, this is not a net new deployment when you're thinking about in-memory. You've likely already got an enormous amount of investment in your existing infrastructure around your existing data warehouse. Perhaps you're running some Hadoop applications, web properties. So this is kind of how in-memory fits into your existing architecture and really augment your existing platform. The graph you're seeing here, it moves from left to right as you go from real-time ingestion type data over to more archival data. So you can see the MemSQL platform fits at the beginning of this graph. So as data is coming in from real-time data sources, you're going to be capturing that into the in-memory platform. It's really going to be able to absorb the significant amount of ingest that you're doing, and perhaps you're going to be doing some analytics on the fresh data as it's in the in-memory platform. And so that's where the application will connect directly to the in-memory database at that point to do that level of analytic. Now, at some point, it's going to make sense to not have this in memory for most people. Maybe after a week, the data is less important or the access pattern doesn't need to be as extreme. It needs to be able to connect to the in-memory database and store it in a traditional data warehouse or a Hadoop cluster. So connection to that must be possible. And then, of course, that data can reside in a less expensive medium from a long-term perspective. So that's essentially where in-memory technology would fit in the context of a traditional database and existing application framework. So now that we have sort of established the basics of in-memory technology, I want to focus a little bit more specifically on MemSQL itself. So MemSQL itself is an in-memory database for fast data processing that allows you to extract very high value and deep insight in real time, exactly the sorts of things that we were just talking about. So some of the key features and probably the most important components, the first is rapid data loading and query execution. This is the world's fastest in-memory database. It's been built from the ground up specifically for memory, and we're going to go into some very deep technical points as to what differentiates and what allows us to make that claim. Very easy horizontal scale, and this is on commodity hardware. So again, sort of along the lines of next-gen big data thinking, we're not requiring you to buy big, expensive vertical scale boxes. You're buying inexpensive commodity servers to scale this out very, very wide. And exactly how wide, we'll cover a little bit later, but we're talking hundreds of nodes scale here, not dozens of nodes, to give you an idea. So native SQL support for both relational and JSON data. Now, this is a unique feature that we've implemented here very successfully. The idea is that you probably have a mix of relational as well as semi-structured or unstructured data. If maybe it's event stream or sensor data alongside your actual relational data. MemSQL actually allows you to store both of these in the same data structure. So you can have both of these things alongside each other and actually write standardized SQL queries that touch on both. And this can be very, very valuable depending on your requirements. And the final thing is it's a drop-in replacement for MySQL performance and scaling problems. So to be clear, and we'll cover the technical bits later, MemSQL is not in any way building on MySQL. This is a brand new relational database that's been built from the ground up, but we have chosen to emulate the MySQL wire protocol, which does make it a drop-in replacement if you already have MySQL, and it generally means a very simple migration if you're using another type of SQL, such as Microsoft SQL Server, Oracle SQL, those types of things. It tends to be a very natural migration. And while you may not have heard of us, we're actually very widely deployed at a number of very large entities, a couple of which are listed here. And we'll talk about some specific use cases later, but again, thinking hundreds of nodes scale. These are not little, 1-2 server deployments. We've got folks like Zynga running in excess of 500 nodes in one cluster. So very, very interesting ability with this technology. So with MemSQL, it's really going to allow you to extract the full value of your data. So the first thing is we want to energize the data warehouse. No longer do you need to think about batch loading. You're not taking a terabyte flat file and trying to stuff it into a database overnight while your analysts are asleep. This is something that you can actually stream data into in real time. Although, just as a side note, if you do need to batch load, it's very, very fast at that as well. You can power operational analytics. The idea here is to make and automate data-driven decisions in real time. So whether that means displaying a real-time graph to your NOC and your ops team, or it means automating a decision where we actually react in code to something that's happening, MemSQL can power that experience and does so successfully. We also want to accelerate applications. As we touched on the previous slide, dropping this in to replace an existing RDBMS is a great way to fix performance application issues without re-architecting your app. One of the biggest pain points we see in the big data movement today is people going, I really want to try Hadoop, but I've got relational data and I've got an application that's depending on relational SQL, so now I have to scrap everything and start over. And with MemSQL, you don't need to do that. Everything stays in relational space. You don't need to change your application. So it's a big benefit from an operations perspective. So how do we accomplish all these things, specifically, especially for the technical folks on the phone? You're probably wondering, this all sounds great. There's a lot of great slideware out there. I'd like to spend some time covering the technical highlights of what MemSQL delivers and how this all works. And then better yet, we're actually going to show you this working so that you know it's not just vaporware. So the first thing, and probably the most important reason that this is possible, is because MemSQL has been built from the ground up with lock-free data structures that ensure high throughput. It also allows for fully concurrent workloads. The way we do this is through multi-version concurrency control, or MVCC, and lock-free indexes, which ensure that writes do not block reads. Now, this is really the key because this is what allows you to simultaneously do OLTP